Good evening. Hope you can hear me okay. I've had to double check on the mic again, but hey, there we go. Right, a little bit of an update. Well, a little bit, fair bit. We've got the main drive systems in, the belts up top. I will pan the camera around later if I can keep my hand steady, that is, and have a zoom in on how all the drive system works. We're just running on 20mm polyurethane reinforced belts. I did request fibre reinforced for some reason. He said to me they are reinforced. Okay, they're fibre, yes. Got them. I've had them for months because I haven't needed them yet until now. Cut them and they're bloody steel. Oh well, what can you do? I'll make best of it and then upgrade it at a later stage, but just not through them. The telescoping arm is in. Bit of tweaking, as you can hear. And then, not quite right, but so I've got very intricate guitar maybe, I don't know. That works, just needs a bit of playing around with. The rear belts are put on, the X drive is on. I just haven't put the belts in yet because I need to finish the tensioners for it. On this, with the belts in, there's a bit more pressure, a bit more force, so it's not moving as nicely as it did last time. As you can see, it's a bit more effort there. At least I know it should stay nice and solid when it's printing or machining or scanning. So it should take a bit of force to put it out of place. So hopefully that'll be beneficial, not detriment. But yeah, we'll see. Bed is giving me jip. Oh well. And hopefully going to start on the tooling face because it's going to be a manual tool changer. So I've got 3 different tools I want to be able to put on here: the 3D scanner, the pellet extruder, and the spindle for cutting. 3 axes to begin with, I've probably said. Eventually I want to advance to a 5 axes on this. If it does well enough to be able to afford to do that, like anything. The tooling plate, I'll just ring down here. Right. Nice and simple, 10mm steel plate. I've only cut the size, I need to drill it out yet. And then it's got a packing plate because I need to stand it off from the top of the gantry. So packing plate is just going to go attached, bolted, whichever way I'll figure out what I want. I'll probably weld it on knowing me. And then this will just go over the top and that just acts as a standoff. And on there I have, lean down again, some extra rails. I'll show you that. Just an extra set of 25mm rails which I was using for the back of the light system, light heating system. That moves up and down to try and keep the stresses off the material. Hopefully monitor a temperature if I can get up to that sort of control stage. Just to reduce the stresses. As you're printing, as you probably all know, the higher you go, you lose your heat from your bed. So you go too high, you start getting debonding, delamination, whichever way you want to put it, and it just peels away. Once the stresses, if the stresses are reduced, that's not likely to happen or won't happen at all. Just want to keep the cooling of your material. As it cools, you want to keep it cooling down at a slower rate. That's the idea with the infrared lights. So hopefully that works. It's all theory. Obviously I haven't put it in practice because this ain't finished yet. But yeah, in theory it should work. But we all like a good nice bit of theory. It's practical that counts really. But on this is going to go onto the tooling plate. Cut 2 sections out of this. So each one of these will go on each of the tools, and then the bearings will go on the face. So hopefully, fingers crossed, I should be able to just push that in, lock it off, and I've got the tool in place. And to help that, 1 second, going down again. I have some Molex connectors, if they let me, heavy duty connectors. Right, so, male and female, get on the camera properly. Right, these are screw terminal ones, that's why I wanted these. It costs a little bit more because of that. because of the brand, and they are heavy duty. I've seen a lot of these used in the industrial. So I wanted screw terminals because while I'm tinkering around and moving things in and out and playing with things and want to move things about, at least I can just disconnect and reconnect what I want to do. This is only a 28 pins, so it's not quite enough for all my tools. So my main power is going to run through these, and then what I'm going to do is all my signal I'm going to run off a relay. So then depending on what tool I put on, it will open up certain relays and allow them signals to go through the same set of terminals, same set of connections. That way I can double up or triple up, whichever way I want to do it. So my signals from my servos, especially when I go 5 axes, eventually I'll end up with 3 servos just on the end of this machine. Obviously not on the tool, because that's what these are for. So there's a lot of cabling, and then you've got the spindle. I made that mistake as well when I fitted everything for the telescoping arm. I put my pipes through, thought, yeah, I've got my air, got my coolant, run it all through, thought, hey, I need a return. Okay, so I've just got my coolant now, so no air right now. When I take it apart at a later stage, if I have to, I might try and think of a workaround, but we'll see. But at least I've got the coolant for the spindles, that's the main thing. Anyway, excuse me. Put this back. Right, the arm. Right, I'm going to operate. I've got a little tool, kind of botched together, a little key. I know it kind of resembles something out of a, find the word for it now. No, Bruce Willis. No, lost it. Anyway, that goes into the RAM drive up top, and that should allow me to manually. It's a bit noisy, so as you can tell, so I'll cover up my mic a little bit, and I won't talk while it's manoeuvring up and down. So at least you can see that moving. Okay. Up we go. It's a little bit noisy. Right. See if I'm going the right way. We'll see if it lets me get it in there. There we go. Right, I'm going to cover up my mic and I let this drive. That works. I'm going to take this all the way down as far as I can, because then we can have a peek inside in a sec. Here we go again. Right, there we go. Sorry about that. A little bit loud. So, the arm is set up for 1.8 meters max extension. Unfortunately, my roof height is not quite big enough, so it's I kind of future-proofed it by accident. Oh, I can do that. Hopefully, if I get to a bigger site, I can just bring it up. I might just extend the lower level and bring the whole system up and then drop the bed, so I can get the whole 1.8 meters, or maybe just make a bigger one. Anyway, so the arm's down. Right, so the reason on this is holding twos. I'm using a worm screw. The reason I want to use a worm screw, so I didn't have to worry about this just deciding to drop on my head, which is kind of a good idea, or just drop and hit the deck and damage the tool. Providing the worm screw doesn't break, this should stay in place wherever it is. It's a 10-to-1 ratio, and then I've got a 25mm ball screw, so plenty of holding force, in theory, again. Well, we'll see. So, I'm going to grab the camera. I might cut this bit depending on how bad it is, and I will start doing a little walk around up and down the, it's there somewhere, here, yeah, up and down the arm, and you can see how all that is put together. Please excuse it, it's a mess, but it works. Function over form, I say, and as you can tell, looking at me and my videos and my go-to workshop t-shirt, yeah, function over form, definitely. Right, I'm just going to grab the camera, give me a moment. Going from the top. And I will tell you what, I will navigate myself up to the top properly so you can see the worm screw. Right, so worm screw. There we go, nice and simple. Hopefully you can see that okay. Hopefully the light's good enough. Right, my x-axis is there together, with the light, but I haven't finished the tensioners yet, so no belts on it. So, quite heavy duty. I like my 10mm plate, it holds everything, as you can see, it's everywhere. And got nice high-in rails. Right. First down the back. So, 25mm ball screw, all my cables running through, and nice bit of drag chain. And then that just goes all the way down to the floor. Aha. As you can see, look, rough, but functional. Right, back around to the front. Okay, there you go, see, ball screw in the back, cable, chain, all the high ring rails. This is terrible. Right, so the idea on this is, if you can zoom, I'll hold. This section here is connected to this arm here, so that's the lower part of it. Needs a Kevlar cord. Right, so that's the lower section, that fixes that in place. This upper section is connected to the next stage. So you have your main stage, holding stage, first stage, second stage. So it's connected to the second stage. Excuse me. So when this first stage moves, this stays still, in turn moves the cord, in turn moves the next stage. And then we just repeat. Next one. So that's the second stage, connected to on the lower section, connected to the first stage, yeah, and then the upper section's connected to the third stage. So, yeah, again, when the second stage moves, the third stage will move. So, in theory, all of this should move in uniform. We will see. Sorry if this is a bit unstable, my hands are terrible. Right, I'll give you a rear view, not of me, don't worry. And that's the Y. So on both sides. Yeah. So two 20mm belts, like I said, polyurethane reinforced on the pulleys, and then I've got a 400 watt JMC servo, yeah, again pulleyed to drive the y-axis. So hopefully it'll work that way. But I've got 800 watts and it's stepped down quite fast, so there should be plenty of torque. There's only one for the X, but I think that should be more than adequate. The rails do allow it to move quite freely. And then obviously another servo for the Z or Z axis. So, right. bit more onto the light system, which is not the frame. Well, the gubbins is there, but it's not quite there, if you know what I mean. So 25mm, like I showed you earlier, we've got 25mm. Get this out of the way. Standard rails. I didn't need anything really special because this doesn't have to be highly accurate. And then just on a overkilled frame, and then this frame here, on the battery. This frame here will have another frame going all the way around the inside of the printer, and that should allow me to attach all the lights, all the infrared lamps. It's about, I've got 3.2 kilowatts, so 16 lamps at 200 watts a go, and then basically traverse up and down. Base tensioners, I've done that both sides, so I've got plenty of play as well, plenty of room to tension up. Right, I'll have to edit a bit of this, I think. Right, pellet extruder, as I've shown before. So this is from Robot Dig, a couple £100, as said in previous videos before. So that is going to attach to this. This is a planetary gearbox, 20:1, so plenty of torque. The servo is rated at peak 4,000 RPM, ideal 3,000 RPM, so 3,000 RPM, 21, you're doing the maths, plenty. This supposedly is rated at 30 RPM. We'll see. We'll see. So 2 kilos an hour at 30 RPM. We might be able to do a bit better than that. We'll have a play. I've got another one anyway, so put that down there, and then that attaches to that. Hopefully. It looks like it should. So it looks like it does. Yeah. Okay. And as you could tell, that's quite a long bit of kit. Altogether, excuse me again. Altogether it's about 600mm. Just the pellet extruder, the planetary box, and the servo. So I've got a bit of play for a pellet box, feed box. But since I'm doing a tool change, I didn't want a great big pipe. I don't want a great big pipe sitting down, filled up with material. So when I change it out, it's just everywhere. So what I've opted to do, what I'm going to opt to do, is I'm just going to do a load box, so to speak. So I have a box on the pellet extruder, and then over that way, in the corner, I'll put a feed, basically a feed box, and that'll be on work on the same principle. So I'll put a sensor into the pellet extruder. So when it runs low, it's sent a code to go to the corner, and then a vacuum will basically deposit material up to a field sensor load point. That way I could probably hopefully get, let's presume 4 kilos of material, depending on the material. Obviously densities vary, so depending on the material. So say volume wise on a base ASA, I'll aim for about 4 kilos, maybe 6, so the machine can run for 3 hours at a time before having to load, and then basically just go from there really. We'll see how much volume 6 kilos is first. So we'll go from that. There's not much else at the moment, unfortunately. Progress is steady, but not fast, because I can only do Saturday, Sundays. Luckily this weekend it was bank holiday over here on the 30th of August, I believe now. Anyway, it's bank holiday Monday, so I had a 3-day weekend bonus. So I got to do another day down the workshop, which was nice. And then hopefully next weekend, or it's Monday now, so this weekend, I can get on with the X-axes, finish that up. I've got my cable chain coming now, actually today. I had a little message earlier, so that should be at my house now. So I'll bring that in, I can start running the wiring for the rest of this, and then start work on the electrical box, which should be interesting. We'll see. I hope you get it working. That'd be nice. All this, I was a little bit past my deadline. I said to myself, I'll be done by April, spring this year. Nah, not done. Oh well, I might say prudent planning prevents poor performance, and no prudent planning here at all. Oh, well. We'll keep trying, keep moving, keep progressing, hopefully keep progressing and not take a big step back. And if you're watching, thank you. I appreciate you watching the video. If you're watching up to this point, thank you. Brilliant. Don't forget, like everyone else says, don't forget the thumbs up. And please, if you're interested in this sort of tech, there's other silly things I'd like to get done eventually, not just to this. Also have a nicer, bigger filament extruder in the back eventually that will get built up once this thing's done, as well as other little toys I want to play with. That's what we do with full-grown men. We don't stop playing with toys, the toys just get bigger and a lot more expensive. So, yeah, so if you like this, brilliant, thank you, appreciate it. Make sure the thumbs up again, make sure you subscribe so you don't miss out on any other videos, updates. I would say I'll try to do more updates on a more regular basis, but unless there's something to show, it's not really worth wasting your time with a video. So I'm all for, I'll say quality, but look at me. I'm all for quality over quantity, and hopefully a couple more videos and then we should be able to start laying down some material. Calibration stage will be a fun one because I've been trying to find someone who does a step-by-step video on how to calibrate a pellet extruder. Filament extruder, easy, 100 mils, you know, set for 100 mils, and then calculate the difference and add your steps accordingly for your E-steps. Okay, fine. We've only got pellets. How? I don't know. We'll find out. But trial and error of everything. So I can go up to 500 degrees on this thing anyway, so I won't be able to put anything through it, we'll see. Be interesting. But again, thank you for watching, and I will catch you on the next video.